To survive on long space voyages, human beings have to be self-sufficient. This is only possible if one creates a life-supporting ecosystem small enough and tough enough to fit on board a spacecraft. Men and women need oxygen, water and food. These consumables weigh around 5 kilos per person per day. Today's spacecraft aren't powerful enough to carry the hundreds of tons of provisions needed for medium and long-distance space travel. The solution might be what ESA scientists have been working on, a support system called MELiSSA, short for Micro-Ecological Life Support Alternative. The idea is to recreate, in a small environment using very little energy, very little space, and with no risk to the crew, a mini-Earth which would allow astronauts to remain in space practically indefinitely. MELiSSA aims to produce 100% of the oxygen and 20% of the food needed by a human being by recycling organic waste, carbon dioxide and minerals using the sun as an energy source. The whole system depends on a series of bioreactor compartments which, by continually breaking down and transforming waste, produce the different elements needed by the crew: oxygen, food and water. All the different phases of recycling rely on the presence of bacteria. As part of a network of partnerships supporting MELiSSA, the Centre of Nuclear Energy Studies in Belgium is involved in the study of a key bacteria, Spirulina, a form of algae that produces fatty acids, minerals and vitamins, as well as producing oxygen.
We use different types of bacteria to degrade organic waste, to purify the water, but also to produce oxygen. And to produce oxygen, we use this green bacteria that can do photosynthesis.
If this bacteria is to be used as part of a future life support system in space, it's important to know how it will behave there. To this end, examples are sent to the ISS where they grow for 10 days before coming back to Earth to be inspected in detail.
Well, we know some bacteria are growing faster under space environment, but other bacteria become, for example, more resistant to antibiotics and could be a risk for the crew members.
In Barcelona, these lettuce seedlings represent the completion of MELiSSA's artificial ecosystem cycle. They also pave the way for other applications. Studying the cycle that turns waste into consumables is also important for us here on Earth. 50% of everything a greenhouse produces is waste. So if you can reuse that 50% of waste to grow another plant, for example another potato, well then you're going to reduce the environmental impact of your greenhouses. While you can't invent life and create something from nothing, you can transform one thing into another. By cultivating and harnessing the energy produced by this process, humankind might soon have the right support for its next step in space exploration.